And our speaker right now is Barak Yenier from Ubercloud Experiment, and the title of the talk is Paving the Way for HPC in the Cloud. With that, please.
Thank you. I know a bunch of you are still trying to settle down, but I will get started. I got only 15 minutes. So the HPC experiment was started middle of last year, and the topics that we wanted to get a good handle on was, if HPC is growing so rapidly in just about everything but high performance computing, why is that? So we are looking at what are the advantages of high performance computing in the cloud, what are the barriers, what are the challenges associated with it. We started by talking to people, just like any good researcher would, and we started to see that there were very common themes. People were worried about their intellectual property. They were worried about data transmission speeds. They were worried about, does my application really work in the cloud? They were worried about, how do I get my licenses there? And we figured the best way to sort it out was to do an experiment. So that's how the HPC experiment got started. It's a volunteer effort. It's completely free for all types of attendees. So we have 4 groups of people who participate in the experiment, and we believe that they're all essential to making HPC in the cloud successful. The first and foremost is the end user. We go after industry end users. We are not an academic research group. So all of our end users happen to fall into that realm. The second group of people are the ISVs. They bring their code in so they can be run on the cloud resources. The next group are the experts. These are people who understand high performance computing and various types of simulation. Because HPC is used in so many different ways, we rely on this group of people to bring in that expertise. And finally, the last group of people are the resource providers. Now, let me be very clear. When I say cloud, we talk about any type of remotely accessible high-performance computer out there. We have a lot of providers who could be in the HPC space, like a lot of the colleges are volunteering their resources. And we do also have some, like Amazon, AWS type of providers in the program as well. So currently we have 450 participants, and as I said, they fall into those 4 buckets. We organize them into teams, and each team happens to have an end user, a resource provider, a software provider, and an HPC expert, all coming in to solve the end user's defined problem. So far, we have completed 60 experiments this way, and currently there are another 15 on the way. So we are expecting to have another 30 to 40 finished before the end of the year here. So I will take you through one of the experiments. We call each of our teams by a number. So this is team number 26, so that you can kind of walk through how this all worked out for this specific team. What they were looking at was their end user is a large global medical product supplier. This end user was using very specifically the Similia product. Whichever product the end user is using, we bring that into the experiment. So we rely on the participation of the ISVs in that way, and many of them are a part of the experiment already. We also relied on a remote visualization product by a company called NICE out of Italy. And we brought in SGI, who was, again, voluntarily participating in the experiment. We brought them to work on this specific use case with the end user. So when we put this whole team together, we also added one more person out of our own group, and that was our team mentor. Each group is supervised by a team mentor so that they don't, let's say, fall off the tracks. So we kind of keep steering them in the right direction. So what was this team trying to do? They were trying to see if Abacus would be able to run to their expectations in a cloud-like setting. Their very specific use case was they wanted to see if, in the case they ran out of capacity, could they burst to the cloud? They have their own internal HPC infrastructure, but in certain times it may not provide adequate capacity. And they also wanted to see if remote visualization would be able to keep up with their demands in terms of having desktop-like feedback as they are doing their simulations. So on the SGI environment, they have built the case such that they would move in their data into the SGI environment. The end user was sitting in the East Coast. The SGI servers were in Silicon Valley. And they moved in their data. They did remote visualization until they were satisfied with the parameters they got, so they could do very rapid prototyping. And once they finished running that entire job, they took their data back in one shot. So they were not transferring the results all the time back and forth, because that would be very time consuming. So as an offer to this end user, they were originally running with somewhere in the range of 40 CPUs in their normal environment. They got to go up to 128, and they were able to also interact with the application remotely using the remote visualization. So what they shared with us was that the remote visualization capabilities were more than satisfactory, and they could get almost desktop-like interaction. So we were able to, in that sense, see that one of the problems that is very commonly talked about does have a technology solution. So the recurring theme of the experiment is that each experiment team runs into certain sophisticated challenges, and they try to look for ways around it. One organization may not be able to solve all the problems and weed them out with HPC in the cloud, but when you put so many experiments together, you have a better chance of, in parallel, solving different problems and see them in real usage. So the general pattern we see is that many of the technology components are actually available and in the market today. So some of the challenges they ran into, we asked every team to come back and report what their results were so that we can collate them and offer them back to the community. So after every experiment, we publish the report so that other companies can enjoy the benefit of learning from the people who discovered how to solve the issues. So again, every single problem that they ran into on this board, they came up with a solution to it. And we also go back to the end users and ask them, what did you achieve out of it? And a lot of times they tell us that they were able to successfully get the use case done, so that if they needed cloud capacity in the future, they would be able to, with confidence, get their hands dirty in a real production environment. So the breadth of the experiment is that we started mostly with computer-aided engineering, mostly CFD workloads, and now it's expanded into bio and big data as well. So as we get end users from different walks of life, we bring them into the experiment and we expand the test cases that we run. I want to point out, not all teams become successful at the end, and we do not try to make them successful. So if a team fails, we simply report on the result of why it failed. So I know when you look at use cases, one of the biggest drawbacks is, well, you only write the successful use cases, so how do we ever learn about where the real pitfalls are? So the HPC experiment is actually a good way of figuring out what the failure points are as well. So what do we do to try to make them successful are just a few things. I will only concentrate on the most critical ones. We do not let the teams just apply whatever process they want. We have defined very detailed steps so that we can take the end user and the other participants through the experiment so that they don't at least fail because of project management reasons. So we help them with project management. We have team mentors who are volunteers. we attach them to the project as well, so that the people who are engaged in the project, if they start veering off the tracks, we can bring them back in and apply the methodology that we know to work. We also offer the community capabilities so that they can advertise very specifically to this group of people, so that they, the people who are interested in HPC in the cloud know that there are vendors out there who can help them. So currently the participation of the experiment, again, is 450. I have a bunch of their logos up there so you can see them. And we believe that this problem of HPC in the cloud can only be better investigated and better researched and resolved if the participation of the experiment grows even further. So with that, I will just slow down and take any questions from the audience.
You quickly went over the slide with the reason for failure. Can you put it up, please?
Yes, certainly. So the reasons of failure very commonly are cases where, for example, the ISV was not quite ready to make those licenses available. I'm not suggesting the ISVs are causing any sort of problem. They are not. However, specific ISVs are further ahead than others. We've also seen challenges that are very typical IT-oriented. The client could not even open the firewalls. We have run into situations where, because it's a volunteer experiment, people just lost interest. I mean, very common failure scenario as well. But we think that as the community picks up more and more speed, these failure points will all get weeded out. And as we learn from the experiment, we put checks and balances so that they occur less often. Any other questions from the audience?
There's a question there.
It sounded like that the companies that were participating, the users, were being given a lot of gratis services and help. Is that correct? Did I understand that? They weren't paying.
You understood it correctly. There is one important aspect. I'll get to it after your question.
So I'm curious as to what's the next step, particularly for those who succeeded. Are they willing to move forward now and pay for the services?
Excellent.
What do you think is the business model that evolves once the free help and assistance, has been exhausted?
Very good question. So let me talk about the limit of the free help and services that they get. So we limit the projects to 1,000 CPU core hours, which isn't a whole lot, but it is good enough to discover whether your particular application runs with reasonable performance in this scenario. So your question is very, very to the point. The next step is we have already went back and offered to the successful teams the ability to go commercial in a very, let's say, well-defined way again. We said no projects over $10,000. We are not making any money out of it again. The HPC experiment doesn't get paid for it, but the providers do. So now we are taking them one more step ahead with, again, baby steps so that they can get closer to real production runs in the future. So there is a commercial angle provided by the participants of the experiment who have commercial interests.
But are the users taking them up on
that? We have sent out the email just 2 days ago, so I would have to get back to you on that. There's a question right here.
We have at least 2 customers who are actually doing all of their simulation in the cloud, the Amazon cloud in particular. Are you, one of them is a Blue Origin, which makes sense since it's owned by the same guy that owns Amazon, but They do a lot of simulation. Did you talk to any of the people who are actually doing this on a regular basis, or is this purely the, experimenting with people who are new to the cloud?
A lot of the people we attract are obviously the ones who are just trying it for the first time, and that's because we are not trying to advertise the successful ones. We are trying to explain the story of the people who are trying to get in there for the first time. So we are not chasing customers who are on a regular basis using these capabilities at this time. Yes?
All right.
Another question. One last question?
One last question.
Certainly. One last question.
Yes, certainly. Please.
I've got the mic, so I'll ask it. First off, congratulations for reaching out to those who aren't doing modeling and simulation or not doing it in this way to try to build that capability in them. How are you reaching them?
Excellent question. So we have received really a ton of good feedback through Tom Tabor's organization, Tabor Communications. So thanks, Tom. That's HPC, HPC Wire, HPC in the Cloud, Digital Manufacturing Report. So about a third of our participants found us that way. A third found us through our communications through LinkedIn, and the other third was mostly word of mouth. All right. With that, I'll return the microphone. Thank you.
Thank you. Thank you.